So good morning students. So today I am taking class for BSc 5th semester. Now I am going to derive tangential and normal component of acceleration of a particle moving in a plane. So in the last class we have derived the equations of tangential velocity and normal velocity. So today we are going to derive tangential and normal component of acceleration moving along a plane. Okay. So as we know that a tangential acceleration is nothing but acceleration along the tangent to a given curve, right? So tangential acceleration is equal to rate of change of velocity along the tangent. So acceleration is nothing but rate of change of velocity along the tangent. Okay, so now rate of change of velocity along the tangent is same as velocity along the tangent at a time t plus delta t minus velocity along the tangent at t divided by delta t, limit as delta t tends to 0. So this is by using again first principle of differentiation, which we have studied in PUC second year, that is if y is equal to f of x is a function, then differentiation of dy by dx by using first principle is written as limit as delta x tends to 0 f of x plus delta x minus f of x divided by delta x. Okay, so similarly we have taken here that velocity, rate of change of velocity or dv by dt is the same as velocity along tangent pt at t plus delta t minus velocity along tangent at t divided by delta t, limit as delta t tends to 0, or limit as delta t tends to 0. Now velocity along along the tangent pt at t plus delta t is nothing but v plus delta v. So earlier the velocity is v, and after some time, that is after having t plus delta t time, then it is v plus delta v multiplied with cos delta psi minus velocity v at the point at the time t, so v cos psi divided by delta t, limit as delta t tends to 0, and therefore limit as delta t tends to 0, this can be written as v plus delta v into cos delta psi minus here v cos psi at the time t psi is 0, so therefore cos 0 is 1, so this becomes only v divided by delta t, and again limit as delta t tends to 0. Now as delta t tends to 0, delta psi is 0, so therefore cos delta psi is 1, so it becomes v plus delta v, cos delta psi becomes 1 because delta psi tends to 0 as delta t tends to 0. So this minus v plus v get cancelled, delta v by delta t, limit as delta t tends to 0, which is same as dv by dt. So therefore tangential acceleration is equal to dv by dt. Okay, so now tangential velocity, we know that v is equal to ds by dt. This we have derived in the last class. So with this, now substituting this v as ds by dt in this equation, so therefore tangential acceleration is equal to, now d by dt as it is, v means ds by dt, so it becomes d by dt of ds by dt, here d by dt of ds by dt, that means d square s by dt square. So tangential acceleration can also be written in this form, d square s by dt square, d square s by dt square, or dv by dt, both can be written. Next, another form, it can be written as tangential acceleration is equal to dv by dt. Okay, now again this dv by dt can be written as dv by ds into ds by dt, so that because v is a function of s, so therefore dv by ds into ds by dt, so that this ds cancels, again it becomes dv by dt only, so which is equal to, now ds by dt is nothing but velocity v, ds by dt is velocity v, next dv by ds as it is, so dv by ds, so therefore tangential acceleration is equal to v into dv by ds. So there are three forms of tangential acceleration. One is tangential acceleration is equal to dv by dt, so this is first form. Next form is tangential acceleration is equal to d square s by dt square, this is another form, and the third form is tangential acceleration is equal to v into dv by ds. All these forms are tangential acceleration. Okay, so this is about tangential acceleration. So now we derive normal acceleration. So normal acceleration is again derived in the same way, but along the normal. So normal acceleration is equal to rate of change of velocity along the normal. So acceleration is nothing but rate of change of velocity. So normal acceleration is nothing but rate of change of velocity along the normal. Okay, along the normal. So that is equal to velocity along the normal. So rate of change of velocity is nothing but dv by dt. Again, by using the first principle of differentiation, it can be written as velocity along the normal at the time t plus delta t minus velocity along the normal at the time t divided by delta t, limit as delta t tends to 0. So that is limit as delta t tends to 0, v plus delta v minus, here sine delta psi is multiplied because it is the velocity component along two directions. So therefore here we multiply this with sine delta psi minus the velocity at the time t is v, again which is multiplied by sine component, that is sine psi divided by delta t. Okay, so now this is equal to limit as delta t tends to 0, v plus delta v sine delta psi into delta t. Now here, as at time t the psi becomes 0, so therefore this sine 0 is 0, this term will disappear. So we will get only sine delta psi into v plus delta v divided by delta t into, again this can be written as delta psi by delta psi. Okay, delta psi by delta psi, because value does not change. So this whole equation can be written in this form, delta psi by delta psi into this one. So now this is equal to limit as delta t tends to 0. Now what I do, v plus delta v into sine delta psi divided by, I'll take one delta psi here, then delta psi by, and this delta t I will take here, delta psi by delta t. Okay, I'll just change the form, So now as delta t tends to 0, delta v tends to 0. That means v delta v is equal to 0. So v into limit as delta t tends to 0 sine delta psi by delta psi into limit as delta t tends to 0 delta psi by delta t. That is v into, now here as delta t tends to 0, delta psi also tends to 0. Okay, so therefore this is equal to limit as delta psi tends to 0 sine delta psi by delta psi into this limit as delta t tends to 0 delta psi by delta t becomes d psi by dt is equal to, now this v as it is. Now limit as delta psi tends to 0 sine delta psi by delta psi is equal to 1 by using limit theorem. Okay, is equal to 1 into d psi by dt. Again this can be taken as v into d psi by dt can be written as d psi by ds into ds by dt, which is equal to, this is v, then d psi by ds is known as 1 by rho, radius of curvature. So d psi by ds is nothing but ds by d psi is rho, that is radius of curvature. So d psi by ds is reciprocal of radius of curvature, that is 1 by rho. So therefore this is equal to v into d psi by ds is 1 by rho, again ds by dt is the velocity, that is v. So totally normal acceleration is equal to v square by rho. Okay, so this is about derivations for normal acceleration and tangential acceleration. Okay, so in the next class we solve some problems on these topics. Thank you.